Phenol. Can you tell me one method which is already known to you? That is the important method, and even that name reaction I gave. Can anyone tell me?
Hello, Arun sir.
Dow's process. Okay, so all of you copy down this Dow's process first. We will move on to the second method. It's an important method of preparation of phenol. Copy down that Dow's process. So that is chlorobenzene when treated with sodium hydroxide, 623 Kelvin and 300 atmospheric pressure. That is nucleophilic substitution under drastic condition we discussed in this chapter only. So just refer that and review. Now next one is from benzene sulfonic acid. Everybody has forgotten the name. We write on SO3H. Benzene sulfonic acid. Here you have to use sodium hydroxide. See that the liquid, that is molten sodium hydroxide, because if you take sodium hydroxide crystal, it is a, I told you that the camphor like it will be looking, and you have to fuse. Fuse means directly heating in the flame. Okay, so when you are fusing, automatically the sodium hydroxide will melt. That is what represented as liquid, not aqueous. Okay, so once is a very simple process, so that the SO3 group, HA group will be replaced by not OH group. Since that sodium highly reactive metal is there, it will be forming sodium phenoxide. Tell me what is the second step? What is the second step? Tell me, this I told you that the certain things you have to remember always simple steps. You have to convert it into OH. Whenever the reactive metals are involved as a reagent, what you have to do? Acid hydrolysis. Okay, so that Na will go and phenol will be formed. So first process is from, it is all important here because it is a conversion of one functional group into another functional group. See that benzene sulfonic acid, last year, how many of you remember, I don't know, in the more than one functional group, in IUPAC nomenclature, more than one functional group is present, mean that one priority list you have to, priority order you have to follow. In that priority order, next to carboxylic acid, this sulfonic acid is the functional group getting second priority. Okay, so this SO3H is this SO3H is what? It is a nucleophile. SO3H to SO4, OH you remove, OH minus you remove, so SO3H. Now you are getting this. That also should be known to you that this benzene you take, and benzene and the fuming or concentrated sulfuric acid or fuming sulfuric acid you take. Here the SO3H plus and OH minus will split like this. Sulfuric acid H2SO4 will split like this, so it is an electrophile. And here in one of the place, all the 6 places are there in benzene. So one of the place H plus will be removed, SO3. This is electrophilic substitution on benzene. Last year in hydrocarbon chapter, you have studied, see that sulfonation. Okay, so that means that from that sulfonic acid, benzene sulfonic acid, IUPAC name itself, benzene sulfonic acid. Sulfonic acid is the IUPAC name of the functional group SO3H. Okay, in that you just add some pellets of sodium hydroxide, fuse it, and it will form sodium phenoxide, and the acid hydrolysis will give you phenol. Okay, so copy down this. So the first one is allo compound into phenol, one functional group conversion. Now sulfonic acid into phenol. This also again a functional group conversion. Okay, now the third one is from amine, and this is already told to you. See that aniline. Okay, write down the name below every chemical, even if you know also you write down aniline. I told you one diacetization reaction. This first step will be diacetization reaction. Yeah, once again I will teach you in this amine chapter. N2 plus Cl minus. Okay, so this is benzene diazonium chloride, benzene diazonium chloride. Okay, so this first step from here to here, this step is called diacetization reaction. Diacetization reaction. I told you in this chapter only it is equivalent to a name reaction. And what is the condition? The reagent is actually HNO2, nitrous acid. HNO2, nitrous acid. Note down these points. I already told once again, you note down here also so that when two times when you read, you will get it thoroughly. So nitrous acid is unstable, very less stable at room condition. So on the spot we will produce. How we will produce? You have to take sodium nitrite salt. Nitrous acid means nitrite NO2 and hydrochloric acid. When you are treating these two, you will get HNO2. And the product is stable only at 0 degrees Celsius. Okay, 270. This temperature, don't forget, if you don't write temperature, then the reaction becomes meaningless. So at 0 degrees Celsius, this product will be stable, diisonium chloride. Now see what I am doing is just to vomit. Already hydrochloric acid, water is there, otherwise little water also you can add. Slightly vomit, and if you warm, automatically it will be forming phenol. Okay, it's a very simple step. Slightly vomit, it's at temperature 0 degrees Celsius, it is diisonium chloride. Slightly vomit that N2, the plus N2 plus HCl. This hydrogen from water and Cl minus HCl. N2 will be going out as N2 gas, and that OH minus from water will be joining here. Okay, so this is another method of preparation. Again, it is important because one functional group into another functional group. Amine converted into hydroxide. Amine converted into hydroxide, and this one you don't use for aliphatic alcohol because in aliphatic alcohol in one step itself it will form. This Rn2 plus is unstable. Rn2 plus Cl minus, this is alkyl diisonium chloride. This is unstable. So it will not form directly, you will get that corresponding alcohol. So it will decompose into ROH. But you will not get this intermediate species. Okay. That is the thing. And then the fourth reaction. Is very important again because of the starting material, that is from cumene. Okay, so from cumene that in the IUPAC nomenclature I had already included thinking of this place only. All of you should know it is isopropyl benzene. Isopropyl benzene, that is CH under CH is attached and both the sides CH3. This is only cumene. Isopropyl benzene, write down cumene. It is also called isopropyl. This group is isopropyl. N-propyl means 3 long chain will be there. At one terminal it will be attached. Okay, so that is here. There are two steps. The first one is it is oxidized in that atmospheric air itself. Okay, so that write down the product. CH3 and this portion will be remaining same, but that oxygen is attached here. Okay, H is that in between H, this is a peroxide. So the name of this compound is cumene hydroperoxide. Cumene hydroperoxide. Write down cumene hydroperoxide. And here you just use acid hydrolysis by using dilute sulfuric acid. They use it will become phenol. Okay, simple step. But only thing you have to remember what is cumene structure and the second one, the cumene hydroperoxide. Completed. And these are the things. And if some more reactions I will be giving, if you want you separately note down, and if you require you just write down in that. One is that you see that some good idea should be there. See, I'll tell you how you have to think. See this, suppose you have to get phenol. Okay, you have to get phenol. Okay, now I think you will come to know, if you do not know so far, it has been included in the impact nomenclature. But still, again, in the next chapter, you will study. Can anyone tell me the name of this compound? Common name. Salicylic acid. Okay, salicylic acid or salicylic acid. Can anyone tell me that how to convert this? How to convert? This is, you can think of decarboxylation. By looking at that structure itself, you should understand this CO2 going out, meaning hydrogen will get attached in this place. CO2 should go, that is decarboxylation. What is this? This is, anyone tell me? Alcoholic AOH. This is called dehydrogenation. Tell me what is that we have used before last year in the hydrocarbon chapter for methane preparation. I have used it. Okay. What is the reagent name? Soda lime. Okay. Soda lime is a mixture of calcium oxide plus NaOH. NaOH is the reagent and CaO is the catalyst. Here, this is lime, quick lime. So lime word is there, and this is caustic soda. Therefore, soda word is there. Okay, caustic soda plus oxide and quick lime is called soda lime, and heat. Right, and then since the sodium and calcium highly reactive metals are involved, then what you will get? You will get ONA or O twice CA. So here, what you have to do is hydrolysis. Don't forget to write this 1, 2. That is, instead of writing 2 step, I am showing on first step. Otherwise, here what you have to do, instead of H, you have to write Na, then again 1 dash, H plus H2O, giving phenol. Like that, you have to write. This is one decarboxylation reaction. Remember. Okay. And I think that other methods, if you want, you take the already Dow's process, slight modification of Dow's process. Just for information, that is halo or chlorobenzene and plus water. But it is very high temperature steam condition in the presence of silicon. Okay, in the presence of silicon, temperature is 800 Kelvin. This also will form the nucleophilic substitution, that is OH. Right? So with this will come not out. And let us go to the properties. And properties will be very easy because very in detail we have discussed in haloalkane chapter. So here it will be very easy for all of you to get involved. Okay. Now properties first will complete the physical properties. The physical properties. Let us complete the boiling point discussion now. Tell me boiling point. Tell me boiling point of alcohol when compared to. So some different point alone you write, that remaining you can understand. Okay, compared with R X haloalkane chapter we have completed. Hydrocarbon, okay, and even ether. Ether this chapter only, but you can include of comparable molar mass. Comparable molar mass. What does it mean? You take one alcohol, you take one halide, you take one hydrocarbon, you take one ether. All of them should have a very close molar mass, comparable molar. You should not take one. See, suppose for example, you take methanol, and other side you take is CH3, CH2, CH2, Cl. Now you don't compare because this is not comparable. See, only one carbon and one oxygen, 2 bigger atoms are there. And here that is equivalent to what is it? 1 carbon and 2 carbon. That means one extra carbon, 1 chlorine again, it comes in the third period, is a heavier one. Now you cannot compare because here it will be dominated by the molar mass concept. Higher the molar mass, so boiling point will be like this. Okay, but here comparable mass, meaning is what you take one carbon, OH propyl alcohol, and carbon, O This is ether, and again you take carbon, carbon, carbon. Instead of that, Cl you take. Okay, hydrocarbon. What you do? See, butane you take. This is hydrocarbon. When compared to this, all these ether, halo compounds, and hydrocarbons, it will have higher boiling point. Okay, so write down comparable molar mass. If you take, they will have reason. Down you write the reason. What is the reason? One of you tell me. What is the reason? The
Hydrogen
boiling
bonding.
point. Very good. Hydrogen, because other cases here no hydrogen bonding. But here in this alcohol will have a strong intermolecular hydrogen bond. Okay, because boiling means understand the process boiling. Boiling means you are separating the molecules, not breaking the bond. You are not breaking the bond, you are separating the molecules. Okay, so this is one point note down. Here I am comparing with different compounds, alcohol with a different compound. Now within alcohol. So within alcohol, what is that? You take that, what is that? Molar mass. This is point number two. Under the same heading, boiling point number two, or you can take it as ABC like that. Molar mass. Molar mass high means boiling point will be high. This is within the alcohol. Among alcohols. Point number three, isomers. Isomers. I write the only the you can convert it into only that full structure. I am writing only the backbone of that this one, carbon, carbon. So this is N-amyl or N-pentyl alcohol, and this is isoamyl or isopentyl alcohol. Okay, and this is neoamyl or neopentyl alcohol. Okay, amyl pentyl both same. Okay, so the five carbon this I have given. You tell me, Vijay, what is the boiling point order? Boiling point order. Here that formula is C5H11OH. All of them will have the same molecular formula C. Right? And now you tell me what is the boiling point order. The concept you tell me first of all. As
Boiling point decreases with increase in branching, sir.
very good, very good. As the branching increases, boiling point decreases. Now just note on this is the concept. So that means highest will be what? Highest will be N. N-amyl will be having highest boiling point, and then isoamyl will have a little less, and then neoamyl will have the least among this. Concept only remember. Branching increases mean boiling point will decrease because the molecule become more and more compact. Surface area, detailed discussion answer you write on surface area decreases, therefore van der Waals force decreases. Because otherwise all of them are having hydrogen bonding. All of them are primary alcohol. You look at that, all of them are primary alcohol. All of them are having hydrogen bonding, intermolecular hydrogen bonding. Okay, so this is one thing. Fine. Okay, so these are the information related to boiling point discussion. Let us come to solubility. Because solubility we have to talk. Alcohols are very highly soluble in water. Okay, so first you write down that lower members. Lower members, that is methanol, ethanol, lower members of that is ROH. Okay, highly soluble. So you can say that very highly soluble. Otherwise, you can say soluble in all proportion. You write soluble in all proportion. What is the meaning of this soluble in all proportion? All proportion means you take that even 90% alcohol you take, 10% water you take, it will dissolve. That is the meaning of that. Solvent you take very less, automatically here 90% becomes solvent as per the definition, but otherwise it's still you consider, you discuss about the solubility of alcohol. Okay, so that means you take this water as a solvent. What is the meaning of soluble in all proportion? And you take 10% alcohol, 90% water you take. It is soluble. 90% alcohol you dissolve in 10% water, it will be dissolving. That is because of what? The reason is what? Very or extremely strong hydrogen bonding. Hydrogen bonding. Okay, if you want to show that, you can show that R, O, H, bend shape. Here one, okay, similarly, H, O, H will be there. This will be here also true. So now, what happened? This can form a hydrogen bonding. And similarly, this can form a hydrogen bonding. This can form a hydrogen. In alcohol molecule itself, three types. In water is here one ROH. Here one ROH. Here one ROH. That we see that means the intermixing is very only in this side alone that water cannot approach that R. Okay. Remaining all the side alcohol is concerned other than this hydrocarbon that is hydrophobic. Hydrophobic is only one this side water cannot approach. Remaining all the side water can approach. All of it clear? So therefore it is very highly soluble. And here itself you write down as the size point number 2. Point number 1, they are highly soluble in water, especially lower numbers are soluble at any proportion, in all proportion or in any proportion. The second point is as the size of R increases, solubility decreases. Solubility decreases. Because reason it is reason. What is the reason? R is hydrophobic.
Hydrophone.
Okay, and therefore, if large in size, they will block lot of area for the approach of water. Then complete. They will block lot of area region, the three-dimensional region, when the size is increasing. Okay, so size small means solubility high, size is bigger means. Then tell me now, ethanol is more soluble or propanol is more soluble in water? Ethanol more soluble or propanol more soluble?
Ethanol.
Ethanol is more soluble in N propanol, which is more soluble in than N butanol. There is an example for this concept. Right, now the point number 3, the next page I will write for the continuity of solubility. Point number 3. What is the point number 3? For isomers. For isomers. Point number 3 for isomers. Isomers, not boiling point discussion over, but you can see the difference between boiling point and here. As branching increases, alkenes also I told you, as branching increases, solubility increases. Remember that boiling point will decrease, but the solubility will increase. The reason is as branching increases, the hydrocarbon part become more compact. The meaning of more compact is what? Occupy less volume. Occupy less volume. Therefore, for approach of water, it will be blocking only less area. So solubility will increase. This is for isomers. Now you tell me what is the solubility order for that amyl alcohol isomers. Amyl alcohol isomer, you see that neopentyl alcohol will be having more solubility than isopentyl alcohol, which will be having more solubility than N-pentyl or N-amyl alcohol. Okay, this is the example for that statement what I have given. So this is about the solubility description. Not all the concept you write, underline or different color, note down. Then one example also, because you will not remember, so better always write in while reading you have to understand, that's all. Once you do like this, again 2 more chapters to go. Any question, reasoning question related to physical property, you will be able to tackle yourself. Okay. So note down this point. Can I remove? Can I remove here? I don't know whether time is enough for cutting down. Tell me, some of you. Can I remove it?
Yes, sir.
Okay. Solubility is over. Our discussion. These are the things. Okay. Now next is about the chemical properties. Okay. First, chemical properties are just equation of different types, and we understand what are the possible chemical properties. Generally, the definition from the definition functional group, most of the chemical reaction will take place. See, I am taking that COH or will be there, or instead of R only that C is there. Okay. COH bond will be there in alcohol. So this is the functional group. This is a functional group. Most of the reactions will operate on this particular site. That is why it is called functional group. Most of the chemical properties will function on this site. That is why the functional group name is given. Okay, so here, this if alcohol, here there are three cases, three types of reaction we are going to discuss. One is if alcohol acts as nucleophile. Okay, tell me which bond will break. If alcohol acts as a nucleophile, which bond will break?
OH.
OH breaks. Okay, OH breaks. Because once OH bond is breaking here, that is R, that is COH iodide. If this is breaking, then only you will get CO. Here, totally it will become 3, one minus charge will come, and H plus will go. So now this can act as a nucleophile. It is a nucleophile. Okay, and then second one is if alcohol in some of the reactions, alcohol will act as a if alcohol acts as electrophile. Tell me which bond will break.
CO. CO.
That is yes, CO bond will break. Okay, COH. Here this bond will break. And CO, that means carbon will become carbocation. It will show this is alcohol part, and OH minus will go on because this is polar delta plus delta minus. Here it is breaking delta minus delta plus. The nuclear bond is breaking. Okay, so that OH will take that electron, so carbocation will form. Okay, so here this is electrophile. This is electrophile, right? Now the third type of reaction is it will take place in the alkyl part also. Alkyl and OH part. In both the places. Can you tell me one example? Huh? If you just have a flow that have come with the reading and continuously following, you can easily say that. Can you tell me one reaction where both alkyl group and OH groups are involved? Huh? Tell me, this is hydrocarbon part, okay, and this is OH group. Now what happened? The neighboring place. Now see the minus H2O goes. Minus H2O. Now see that what has happened, the OH also reacted, and this hydrocarbon portion, CH is a hydrocarbon portion, so that also reacted. Okay, so in that elimination of water, dehydration belongs to this category. Both alkyl part and OH part will react. Okay, so this introduction you write, and we will move on to the examples one by one. The first one is cleavage of OH bond. We'll discuss first. Okay, cleavage of OH bond, a very important discussion, and many reasoning questions will be asked from this. So listen carefully. Note down three types of reaction: nucleophile, OH bond will cleave or break, and electrophile means the CO bond will break, so carbocation electrophile will form, and both alkyl part and OH part will react to mean that is dehydration reaction. Now here the first one is breaking of OH bond cleavage. OH bond cleavage or breaking. and this comes under this discussion is acidic nature of alcohols. So that means alcohol, see that suppose one R CH2OH I write, okay, CH2OH, and here actually that is CO phase, CO bond is on this one, CH2O, and this one I'm taking as a bigger one. Okay, so all of you know that this is highly polar, delta minus, delta plus. So whenever it breaks, R CH2O minus plus H plus. This is only donating proton. Okay, so we're giving proton, producing proton, therefore it is acid. Okay, it is actually a very weak acid. Okay, very weak acid in some books. Not even it is almost very close to neutral. Neutral because you see water, pure water itself taken as a neutral species. Okay, pure water pH you are writing polar. Okay, but some small, very small 10 to the power minus 17, 18, 20. Minus mean what you know the 0.0000 that value, very small ionization for water. But this is I am going to prove by some reaction, that experimental reaction, that alcohols are weaker than water, weaker than water. That means you see that is one you can say very small acidity or almost neutral. Okay, here because of that they do not. Some points you should know that for the MCQ purpose they do not turn. They do not turn blue litmus even that much weak blue litmus to red. They do not turn that much weak, unable to turn. Because even turning of blue litmus into red, if you study the indicator theory and all, some slight change will take place, that the conjugate acid base change will take place. That is why that color will change. But even that alcohols are very weak in nature, even they cannot turn blue litmus into red. Therefore, definitely they will not react with the weak bases like what sodium carbonate, bicarbonate. They will not react. They will not produce brisk efflorescence of liberating carbon dioxide. Okay, I don't touch that because blue litmus itself not changed mean understood, remaining nothing. That means what they will do is they will react with only strong base. Strong base. Okay, strong base means even I am not taking sodium hydroxide here. I can take that in a very strong condition. So R CH2OH with sodium metal. Okay, sodium metal is a very strong base, and here it will form RCH2ONA. Sodium alkoxide. You write down sodium alkoxide. Ethoxide, methoxide, propoxide, and also I have used the R symbol. That's why I'm using alkoxide with a very strong base, because it is a very weak acid. So in the reaction, what has happened? The proton is given out. The proton H plus is given out. If this reaction can be carried out with a very highly concentrated sodium hydroxide also, okay, sodium alkoxide, it is formed. That is the reason we say that it has a acidic nature. But how can I say that it is weaker than complete this? Yeah. So before going for this discussion is a long discussion. It will go for another 20 minutes or so. But all of you just recall the acid-base concept, especially that Bronsted-Lowry acid-base concept. There is a conjugate acid, conjugate base, because in some of the places I'll be using that concept of that Bronsted-Lowry conjugate acid link. Okay, so I will also tell you now, just recall yourself, recall, so that you will be understanding. We are going to compare the acid strength, which is stronger acid, which is weaker acid. Like that. So that time, the conjugate base only will help. Because acid stronger means conjugate base will be, tell me, Bronsted-Lowry conjugate acid base relationship. Means weaker base means acid will be stronger. If the base is stronger means acid will be weaker. Right. That is okay, correct answer. But tell me, how can you say base is strong or weak? How can you say from which criteria you will say base is strong or weak?
pH.
From the
OH concentration.
no, that reaction you are keeping the text, you are keeping the textbook open. That is why. So you talk about my question is general question that your first statement is correct. Okay, so conjugate acid base is stronger means acid will be corresponding acid will be weak. Conjugate base is weaker means corresponding acid will be stronger. That's what I am going to use here. But how can you arrive at that particular conjugate base is either strong or weak? How can you say from which
pH.
criteria? This from the stability. Remember that point also note down. If the stability is more, base will be weak. The base stability of the conjugate base. What base that we will discuss. Many bases are there. But the concept I'm saying, if the base is stable by resonance, because some resonance I will talk about. That time due to resonance, the base will be more stable. If the base is stable itself, it will not like to accept proton. Accepting proton only, what is that? Broad-shell base. So if the base is stable by its structure, by resonance or by some reason, inductive effect or hyperconjugation, whatever it is, if the base you are conclude that base is stable, it will not have much attraction towards H plus. It itself stable, then why to attract H plus? That means stable means weak base. Remember, and less stable means stronger base. Less stable, so it will like to accept the proton and to become stable, to become alcohol and stable. Right on. Base less stable means stronger base. The base is more stable means it is a weaker base. Then after that, weaker base means stronger acid. Stronger base means weaker acid. This link you just have a. Okay, now I'll now come to the discussion. But before going there, for that, I will prove that alcohols are weaker acid than water. Weaker acid. Acid means what? Acid means donate proton. Donate proton. Okay, so weaker acid than. Now what you do is, I am taking RO minus. Okay, from where you don't think that I am writing only RO minus, but RO minus alone cannot be taken from the reagent bottle. That is RONA. From RONA, this is minus plus. In the reaction, I am showing only minus part. Okay, so now you add H2O, sodium. This is sodium alkoxide, methoxide or phenoxide, sulfate, and then you add water, H2O. It was becoming ROH plus OH minus. This is experimental. This is that experiment. Whenever I write some reaction, it is an experiment. I am not writing theoretically. It is experimentally done. Okay, now from the sodium salt of alcohol, sodium alkoxide, when dissolved in water, alcohol was formed and sodium hydroxide was in a dissolved form. Alcohol molecules were formed. So what it shows that this protoxide, this is becoming this H2O becoming OH minus mean water donated H plus. That means water has given alcohol also alone it was donating ROH was donating H plus to whom? To whom? To NaOH strong base or to sodium and to sodium is treated it was doing that. Giving out and sodium salt was formed. Okay, but R that means ROH also can donate, water also can donate, but this reaction reveals that this reaction when you have a competition between alcohol portion and the water portion, now who is better donor? Here this reaction shows that water donating H plus is a better donor. Water is better donor of H plus. That is why that it is possibly giving that H plus here alcohol molecule is formed, unionized molecule is formed, and OH minus is existing, and because of this reason only. So better donor means what I can say. Water is a stronger acid than ROH. Remember that. Then what about the this is acid. This is acid strength. Now I am coming to the base strength. Base means conjugate base. We call it as a conjugate base. Otherwise, it's a base. Conjugate word is used by Bronsted-Lowry. Otherwise, it's a base. What is the base? If alcohol is donating water, RO minus is the base. If H2O is donating proton, OH minus is the base. Now tell me which base is stronger? RO minus alkoxide is stronger. Alkoxide base, or O minus. Another side is hydroxide. Which is stronger? Here, alkoxide is a stronger base. Remember that. Because water is a stronger acid, therefore its conjugate base will be weaker. Remember that. This is conjugate base. Conjugate base. If this is strong, then conjugate base will be weak. Remember that. I will apply that. Nothing. I am not teaching anything in this one. And you should know. So see, once you have this complete thorough knowledge about conjugate base, acid, everything, you yourself can write. Only thing you have to remember this equation. Then this reaction concludes. This reaction concludes water is a stronger acid than ROH. That's the remaining explanation. What all I gave at the bottom. It is you can also do once you are thorough in this Bronsted-Lowry concept, acid, stability of base, conjugate base, and all. Okay, don't confuse. Don't think that it is this and that. It's a few statements that I have used here and there. Okay, right. Now this is about that acidic nature. Is the actual explanation, okay, by using the stability and all. But what some simple layman we used to say here also I will say somewhere layman explanation. What is the meaning of layman explanation? First of all, why ROH is acidic? Why RO is acidic? O minus plus H plus it is giving. That means it's an acid. The reason is what? That OH bond is polar. The OH bond is delta minus delta plus is a polar in nature due to electronegativity difference. Okay, there is a large amount of electronegativity difference. Therefore, the bond is highly polar, so easily it breaks into H plus and O minus. Okay, this is the reason it is acidic. And I am not coming to water comparison. That is previous page. That is chapter is closed. Okay. Now I am coming among the alcohol. Among the alcohols I am coming. Then after that I will link water. Among the alcohols. I have not yet touched the aromatic alcohol. Phenol. Next discussion is phenol. That's why I told it is a very long discussion. I can directly give the order alone and I can go for the next reaction. No use that issue because every time they ask a reasoning question. They are simple to understand. Right now, I am coming to this among the alcohols. Alcohols mean that is a primary alcohol, secondary alcohol, tertiary alcohol. Okay, let me take one primary, secondary alcohol, tertiary alcohol. First, I take this one tertiary alcohol. I am taking. Okay, this is tertiary alcohol. That means OH group attached to tertiary carbon. This is tertiary carbon. Right. Another one is CHOH. This is the symbol for that I told you. That is that secondary alcohol. This is secondary alcohol because the carbon in which alcohol attached is secondary carbon. Then one primary CH3, CH2, OH. Okay, even after that, without primary, without it, this is special. Methyl alcohol is special case. Methyl alcohol, no primary. Methyl alcohol is not a primary, not a secondary, not a tertiary. Okay, it's a special case. Now tell me, in this out of these, which will be more acidic? Based on this, you tell me. Based on this concept, alcohols are acidic because of the OH bond is polar. More polar means more acidic. Less polar means less acidic. Now you tell me, out of this is tertiary alcohol, this is secondary alcohol, this is primary alcohol, and this is methyl alcohol. Tell me which is the shortest, you tell me which is the strongest acid. then we can make the order, not a matter. Only one thing, which is strongest acid. Which is the strongest acid? Anybody?
Methyl alcohol.
Okay. Reason? Okay, let all of them understand, and I will give the clues. And he has already identified that reason, so his answer is correct. But all of you now, everybody will be able to do. I will just tell you one more step explanation. I will give you COH. Okay, so you know that this is CH3. Okay, CH3. So here, this is delta minus, this is delta plus. By nature, it is polar. I don't talk about this, block this area, okay? Then don't consider this methyl group. OH itself polar, the bond is highly polar because all of you know, you have studied about dipole moment, polarity, when you studied the chemical bonding last year. So any electronegative difference is polar, but here too much difference. Oxygen is second highest electronegative, hydrogen is almost equal to carbon, and with very low electronegative. So now here is polar, right? Now let us see the influence by the neighbor. Okay, let us see the influence by the neighbor. What is this neighbor? It is actually plus I category, inductive effect. Okay, inductive effect. What is inductive effect? Now see, now I am writing O H. That this part I am not taking. It was having, by nature, it was having some polarity, so that it can break and give acidic nature, behave acidic nature. I am not touching that, and that's why I am not putting delta minus now. Now here, this CH3 is there, means that also neighboring bond. So I will put that, means here, what is that? This effect will be there like this. You are studying not inductive effect, plus I effect it is. Electron cloud, the arrow mark I have shown is, this is electron releasing group. Plus I means electron releasing group. Electron releasing, electron density releasing group. So if it is pushing the electron cloud, now tell me oxygen was pulling from oxygen. This is, see that I am next to arrow mark, and this is I am taking electronegativity. Oxygen electronegativity, that is minus I effect by oxygen. That is there in normal any OH, it will be there. But what is the role of the alkyl group? That is the second diagram. The black color I have drawn is role by alkyl group. What alkyl group will tell? Alkyl group will tell oxygen, you take, I am giving, why you are pulling so much from hydrogen? I am giving little electron cloud. So once methyl group is giving electron cloud, oxygen will definitely pull less only from hydrogen. Because its electronegativity is satisfied. Its electronegativity is satisfied to some extent, because the methyl group is giving electron plus I effect, electron releasing group. So it's thirsty for pulling electron, this one, then pulling electron from hydrogen will be less. So the bond become less, OH bond become less polar. Okay, less polar. Tell me here how many plus I, there are 3 plus I effect. One plus I effect itself making less polar. Less polar means less acidic. Less acidic. Okay, so one methyl group itself less acidic, less polar, less acidic, means 3 plus I effect. Here in this 1, 2 plus I effect. Here 1 plus I effect. Here no plus I effect. That means that which is stronger acid. Okay, write down that tertiary alcohol, weakest acid, then secondary, weaker than primary, and then methyl alcohol. Now can I include that water here? Like I don't know, up to this you write. Water comparison, first itself in the first discussion over ROH is weaker than water. But among these ROH only, that is tertiary, secondary, primary, and methyl alcohol order you have written. That means this it is less than, all alcohols are less than water. So I am taking. So up to this you write. Still not over. Now in the right hand side, I will include this phenol category. I am now, this alkyl alcohol is over. ROH is over. Now I am coming to AROH, aromatic alcohol, phenol. Only phenol is your syllabus, not that naphthalene or phenanthrene type of 3 member. Only single nucleus of benzene. Phenol is our syllabus. So phenol will discuss, and whether it is greater than water, stronger than water, or weaker than water, let us see. Then after that, I will combine with this. Okay, at present, you have only this much sequence. Right. Now I'm taking new page. AROH. Right here, first of all, this here first thing is it will turn blue litmus into red. Okay, so that first you will write the introduction. Blue litmus will be turned into red. Okay, but no reaction with HCO3 and CO3 means bicarbonates and carbonates, because these two are weak bases. And this so that means what it shows that blue litmus is converted into red mean. Definitely, this first point supports that the AROH is a stronger acid than ROH, because ROH could not do that, and phenol is doing that. Phenol turns blue litmus into red. That means phenol is stronger than that. And that is one physical criteria. But at the same time, when phenol is treated with bicarbonate, no brisk effervescence, no salt plus carbon dioxide plus water form. That means what is that? It cannot react with bicarbonate neutralization, cannot neutralize carbonate also. That it shows that it is a weak acid. It's a weak acid, because this weak base and weak acid cannot react. At the same time, what happened? It is reacting with strong bases, NaOH. So to form sodium phenoxide, it forms sodium phenoxide. Therefore, it is an acid. Okay, because it is a strong base. A strong base means even weak acid can react with strong base. These are the introduction part. Remember, because distinguish between benzoic acid and phenol. At last, in the next chapter, I will talk about that time. We have to take this reaction, because these two will react with benzoic acid, carboxylic acid. Okay, carboxylic acid, they will react, but the phenol, they are not reacting. So this will be the distinguish between phenol and benzoic acid. Distinguish question, one question sure in board exam. Remember that. That time I will tell you now, not required. Let us complete carboxylic acid also. That I will come to the distinguishment. Okay, these are the introduction part. Okay, now next time coming to that, why it is stronger acid. Why it is stronger acid? Now, see, I am proving that now heading is piece by piece we'll study. Why phenol is stronger acid than, let us study alcohol. Then we will compare with water. Another one is here H water. That I will not add. Another one is ROH. Right? So in all the cases, OH bond is there polar. Delta minus, delta plus, delta minus, delta plus, delta minus, delta plus. Means all the OH bonds are polar. It has its own polarity, so it will break definitely to become acid. Okay, and by ionization. But now, what is this? This is C6H5. This is hydrogen. This is methyl propyl. So this is C6H5 group. This is hydrogen. This is CH3 group or C2H5 group. Now you know this is minus I effect, electron withdrawing group. That's why I see that in class 11 we have studied as a basic. Now I cannot explain that what is electron withdrawing. This is electron releasing group or electron donating group. They will donate the electron density. Now tell me, see, already oxygen is pulling from hydrogen because of its own electronegativity. Oxygen own electronegativity. Now somebody is again supporting. See that this is pulling. Benzene ring also will pull. So oxygen is pulling from here. That is why delta minus delta plus. Now this benzene also will demand, through oxygen will demand, means this bond become more polar than normal OH bond, more polar. So therefore stronger acid than what H2O. Why? Because in H2O only OH polarity, hydrogen no taking as a standard. Hydrogen is neither electron withdrawing nor electron releasing. That means when compared to water, it is a stronger base, a stronger acid. Now come to this one. This is electron. Already I told you, it is the electron releasing. Oxygen atom is pulling from hydrogen, but this R is telling you don't pull much. I will give little. So that bond become less polar. This is less polar, and this is some polar. Normal polarity. The normal polarity. It is more polar, more acidic. Less polar, therefore less acidic. Okay, so this order also. This is AR this order also. So already one order concluded, starting from tertiary alcohol, secondary up to methyl and up to water completed. Now I am including that. See that it is CH3 OH completed. Then water was sorry, not this order. What is that order? The mistake is tertiary weaker, secondary stronger, primary stronger. It is ROH. Alcohol, and then methyl alcohol is stronger than that, and water is stronger than that. Now, can I write that the phenol is stronger than water? So I have added. Still, here some more will come. Here some more will come. That's for the next discussion. Okay, so now see, I have increased the order. That I am extending that order, so that any question asked, you will be able to answer. Let us go to that now. That means among the phenol. Before going for among the phenol, you tell me what is the reaction between phenoxide ion plus H2O. Can anyone tell me what is the reaction between phenoxide ion, that is sodium phenoxide utenil? What is the reaction? Right, tell me. What is the reaction? What is the reaction? Right, nobody this much I have taught what is the use here for one chemical property. I am spending this much time and nobody able to say the answer. Right, no reaction here. How can water donate to this one? Phenol. Phenol is a stronger acid. Phenol than water. Just now I told you. That means phenol will donate proton. Phenol will donate proton. That not that. So here no reaction. But here what happened is phenol stronger acid than water. It will donate proton. So what we will get is H2O will form, and sodium phenoxide ion, sodium phenoxide will be there. Oh, so it shows that it is a better donor. Better donor H plus, better donor of H plus. Okay, understand that? So this reaction will take place. Here no reaction. It proves that it is a better donor of proton than water. Therefore, phenol is stronger acid than water. One point. Another point is I am coming to the conjugate base. Conjugate base. What is the conjugate base? Phenoxide ion, O minus phenoxide ion, hydroxide ion. See, phenol is stronger acid, means it's a weaker base. Its base will be this, a conjugate base will be weaker. This is a weaker acid, then this will be stronger base, conjugate base. So when their acids are having this order, then their base will have opposite order. Okay, this is only for phenol and water I am telling. Similarly, everywhere, wherever you compare, if suppose acid A, acid B, then you know the order means their conjugate base order, you can easily say it is a reverse order. That point we note down. Okay, 2 or 3 acids order, if you know, then their conjugate base order is just reverse of that, according to Bronsted-Lowry conjugate acid base concept. That's all. Right? Okay. 2 points, remember. Now I am coming to among phenol. Among phenols, different phenols. What is that phenol? OH with one CH3 group. OH with one NO2 group. Now tell me which is stronger. Tell me which is stronger.
NO2, sir.
NO2, this is stronger acid. This is weaker acid. What is the reason? Because CH3 group is a plus I effect. See, I'm just showing that with the black color. You see, this is the 1, 2, 3, and then mean 1, 2, whether the effect will be there or not. So, like, it will be less significant after the third bond and all. But still, that the electron releasing effect is here. This CH3 is giving to oxygen. Okay, don't take from hydrogen much. I mean, this polarity is reduced. Polarity of OH bond is reduced. Polarity reduced by the plus I effect, not only methyl, any plus I effect. Whereas this is here what happened, this polarity increases. Polarity increases by minus I effect of NO2. NO2 is a here actually electron withdrawing group. It will pull the electron cloud. That means it will pull from here. It will pull from here. Oxygen is made to pull more from there. It's like that. Understand that? So we remember that phenol. I'm using this symbol for phenol. Phenol attached with electron releasing group is weaker acid, and phenol attached with electron withdrawing group is stronger acid. And what about phenol? Phenol will be in between or not yet? Phenol will be in between or not? Because phenol is not having electron releasing group. So it will have some its original standard form with its acidity. If it is having electron releasing group plus I effect, then less acidic, and minus I effect, more acidic. This is the order. This is the order. Okay, now you complete the order now. Complete the order. Extend that what I gave, including alcohol, water, phenol, the types of phenol, everything together. You write the order. That's all about this discussion on acidic nature. All of you write down that. I will also write, but you write it without seeing this. What is this now? See, tertiary alcohol, weakest acid, secondary alcohol, little stronger, primary alcohol, little stronger, methyl alcohol, little stronger, and water is stronger than any alcohol. And after that, phenol with the electron releasing, that is CH3, this is plus salt. And then stronger is phenol. Stronger is phenol. Again, stronger is what? Nitrophenol. OH, then O2. Nitrophenol. Okay. Order as well as reason. Not only order alone, reason. Okay. Remember, this is very important because now the same explanation I will use in the last organic chapter, amine chapter. In that amine chapter, here we studied about the acidic nature. Aliphatic alcohol, aromatic alcohol in comparison with water. In amine chapter, basic character we will study. In comparison with what? With whom? Anybody? In comparison with whom? In amine chapter, aromatic amine, aniline, and aliphatic amine, that ethylamine, methylamine, that aliphatic amine, and we will discuss the basic nature in comparison with what? Here, water is the standard comparison. There, what is the comparison? Ammonia. And in ammonia, only one hydrogen is removed and CH3 is added, means alkyl amine. Benzene ring is added, means aniline is become. So standard will be ammonia, character will be basic character, and it will be very closely related to this. Only one small difference, some sequence. Anyway, don't think of that later on. We'll discuss in that chapter. Okay, right. Any doubt here from this acidic character? I have completed completely. before going for the second one, let's try one. Some of you will have see that phenol. Phenol is a stronger acid. I am going to prove. So phenol will become. This is also one idea. Okay. So this is phenoxide ion. Phenoxide ion. It is a conjugate base. That was previously I told the layman explanation, but now I will include some very good modern theories and all. See, that one means the type hyperconjugation, resonance, that type of theories I will use. This is phenol. Okay, this is acid. Now, can I say one? This is second explanation. One more explanation, other than the layman explanation of other than the polarity. I'm not going to use the polarity now. That is by using some other stability and all. So, can I conclude phenol is a stronger acid by you proving that this conjugate base is weak base. Correct or not? Yeah? It can be a stronger acid only when its conjugate base is a weak base. Conjugate weak basis means what is that I told you? More stable. What is the more stable? That means this when compared to these two structure, this phenoxide structure is more stable. I am not going to draw. I will just to show you. See, you later on you draw and practice. All of you know you can how to draw the pi resonating structure. Okay, this is OH. First for phenol I am saying, and after that the phenol you try for phenoxide ion. This is I am giving the work to you. It will be available in the textbook, but you don't see that. You work on that your own. Right now, what will happen? This is phenoxide ion O minus. It will have 3 lone pairs. Okay, now I am going to say that this is more stable. Phenoxide ion is more stable, therefore weaker base. It will not have much affinity for proton accepting, therefore it is a weaker base. And once it is a weaker base, according to Bronsted-Lowry concept, that the acid will be stronger. That's what I am going to say. But only one doubt will come in your mind, sir. Phenol and this one both are having 5 structure. Okay, totally 5 structure will come. How the 5 structure will come? See that this one of these lone pair is one of the lone pair. This will come here. It will have a double bond. Next structure, it will have a double bond character. Okay, and this is the thing. This H will be there. Once it is giving here, positive charge will come. Then this will go to here. That means in this there is no bond here. 2 dots will keep minus. In the this is second structure. So next structure this will move here. In the double bond will move here. Here minus will come. Then this will move to this side bond, and this will move come here. Here minus. Then finally it will go. Totally 5 structure will come. Okay, that final structure I am writing. Final structure I am that is resonating structure, but now resonance hybrid. I am writing resonance hybrid. Resonance hybrid for alcohol I am writing phenol. Sorry, phenol I am writing. That is OH. These bonds are not involved in resonance. What I have drawn is not involved, and one lone pair also not involved, and another lone pair involved in one resonance. See that this is the resonance. It came from here. It came from here overall. Step by step I was showing you. This is the resonance. As a result, here there was a delta plus, there was a delta minus, there was a delta minus. This is the structure. Okay, right. Now similarly here phenoxide ion are coming. In phenoxide ion, out of these 3, one will take part here. Okay, one will take part here. So and this will go here. Now tell me only I will show only one structure. Remaining consider and I will conclude. Only one structure I will draw, and this is O, and then lastly I will draw the resonance hybrid. Okay, so now what happens? This is 1, 2, 3, 4. Here double bond character will come. I am not writing plus symbol here. Why? Because that the electron coming here now, that is that minus sign is going out. That's all. Because of minus one extra electron was there. So once it bond comes here, oxygen is still having its electron. Only minus sign will come to this one here. Here minus sign. Okay, then after that this will come here, this will come here, minus sign. Again that one here minus sign. Then go back, you will get the structure. So here what is the resonance hybrid? Here the resonance hybrid will be these bonds are not involved. Okay, these bonds are not involved, and this one of the lone pair is involved in resonance. As a result of resonance, minus delta minus. Okay, this is as a result of resonance. Already this charge was here. Now, what I want to say is here minus was that. That is minus, it was ion, and the delta minus, it's a anion. Here I partially it is like that. Now, when compared to these two structures, this is more stable. I'm saying, can anyone tell me based on which some postulates of resonance? I gave many postulates. More stable, I'm saying more stable. Phenoxide ion is more stable. I am concluding that phenoxide ion is more stable by resonance. Even though both are having same number of structure, you cannot take the same number of structure concept. Resonance subconcept is more is the resonating structure, more is the number of resonating structure, more will be the stability. One subconcept. Okay, but here both of the is about the charges. Okay, any resonating structure of as well as finally the hybrid also, the charge is separation is there means it will be less stable without charge separation. See, in case of structure as well as in the charge negative charge separation, whereas in phenoxide ion there is no positive negative, only negative is there. Okay, so one point is due to the positive negative separation, phenol is less stable when compared to phenoxide ion. One more concept, subconcept. Here, once again, you get a chance to strengthen your idea about the resonance. One more subconcept of resonance is in any of the resonating structure and therefore in the resonance hybrid, because resonating structure only will contribute for resonance hybrid. So whatever you speak about resonating structure, definitely it will appear in the resonance hybrid also. What is that? When you write the resonating structure, not only this phenol, anywhere, is highly electronegative atom, fluorine, nitrogen, oxygen, these highly electronegative atoms, if they carry positive charge, it is not stable structure. So according to this subconcept, again, once again, phenol is less stable. So by resonance, who is more stable? Phenoxide is more stable. Once phenoxide comes to that, phenoxide is more stable. More stable means it will have less affinity to H plus. Because to become stable only they will attract H plus. But it is more stable means it will have less affinity. Okay, less affinity. That means weaker base. Once it's a weaker base, who is conjugate acid? That is phenol. Phenol is a stronger acid. See? By using OH polarity, the layman explanation simply by electron withdrawing releasing, but here it is based on the modern concept, resonance concept I have explained. Okay, so all of you understand that, right? Now, in this structure will help you to understand that what is the effect. Well, simply I did not give. I did not give simply. I am coming to now that electron withdrawing group and the electron releasing group. I will draw a very big diagram of phenoxide. The phenoxide ion only help you to conclude that phenol is stronger actually. Okay, oh, right now here what you wrote, that is I will just you are showing that this is the resonance hybrid of phenoxide ion. Okay, minus delta minus here delta minus. Okay, right. So now that is the I am coming to this one electron release here, electron releasing group, CH3, electron releasing group. What is this electron releasing group? This is plus I effect. Electron cloud will be pushed. You tell me when already in this place there is a negative charge developed. Negative charge, partial negative charge developed. Partial negative charge developed. Okay, developed and by its own, without the CH3 itself, negative charge is developed. Its own. But when CH3 comes, what happens? that negative charge increases because already negative charge electron rich, and this also electron releasing group. So that means I already told you carbon ion anywhere that means electron releasing group will destabilize. Understand? It will destabilize. Become more negative charge it becomes. More is the charge, less will be the stability. Okay, so that means the stability of phenoxide ion decreases. What about that acidic nature of that corresponding alcohol? Tell me, acidic nature will be what happened? This see because of this stability, stability increase. No, wait, let us go
Decrease.
step by steps because many of you are not understanding. That's why I'm going step by step. Stability decreases. I'm telling when compared to without CH3, with CH3, stability decreases. Once the stability decreases, it becomes what about the basic nature? Basic nature increases or not? The basic nature increases or not here?
Yes,
And
sir.
therefore that conjugate acid corresponding phenol acid, conjugate acid will become weaker acid. That is now you look at the order. Cresol is weaker than phenol. See, this is phenol, and CH3 comes, it becomes that acid becomes it is that phenol becomes the cresol becomes weaker acid. Right? Now next is suppose I am coming to this side. This is already over. Okay, don't touch this. Now instead of erasing, I am coming to this side. Okay, suppose one NO2 group is there. NO2 minus I effect. Okay, minus I effect means what? It will be electron pulling group. Electron pulling group means you tell me the delta minus will decrease or will increase? Will
Degree.
decrease. Charge is decreasing because the electron density only indicated by delta minus, and that electron density is partly pulled by NO2 group means because it is a minus IF, right? Electron withdrawing group. So that means it will pull mean that in this place the negative. So charge decreases. Charge decreases. Stability will increase. Remember that. Stability increases. Stability increases means again it becomes weaker, further weaker base. That means the acid will be further stronger acid. That is why nitrophenol is stronger than phenol. See, so that is the ordinary explanation I gave that, but here with the help of resonance structure, by the resonance modern concept I have explained. Okay, so this is end of this discussion. Okay, now before going for the next property, my question is: can alcohol or phenol act as a base? So far, I was telling alcohols are acids weaker than water. Phenols are acids stronger than water among phenol, among alcohol. But can alcohol and phenol act as base in any of the reaction?
Yes, sir.
The higher
Huh?
acid.
Okay, can my question is yes or no question.
Yes, sir.
Lube is base. Okay, so question. And you told that yes, sir. Now tell me why yes. Because R O H it has got a two load pair. It can be donated. That's why load is base. What is load is base? Can donate electron pair. Electron pair. Generally, it will be unused electron pair, lone pair. So here it has got two. So oxygen has two lone pairs. See example. ROH. You treat it with sulfuric acid. Concentrated sulfuric acid. What you will get is ROH. Here one H will come only one lone pair positive charge. Why? Because this sulfuric acid is giving H plus. Huh? That H plus will make a bond through this one. Here there were two lone pair. One lone pair made a bond here. Between only one pair. Then the oxygen overall net effect is one electron less. So the positive charge comes here. This is the reaction. So this point also note down. Or because this has been asked as a reasoning question in your exam. That is why I mentioned this. Okay, right. And now one more reactions we'll study. Still time is there or no time? much time more? How much time more as per our normal calculation?
8
Started
minutes, sir.
15 minutes more, sir.
10:20 I started or 10:15 I started? Or
10,
10:10 I 10?
20,
Ten,
sir.
ten.
Right? 10:10 or
10.
10:25 or what?
10,
I am
10,
my watch.
20, sir.
The watch is on that on my laptop. That is according to that. 10:25 I started. Huh? That means 11, 12, 25 I have to finish. Anyway, even I am taking your time. 10:15 we started. Okay, that means 12:15 means another half an hour left. Another half an hour
Yes,
left.
sir.
That is for normal time, but we always go for excess. We are Chinese school cadets here, not a municipality school or government school. So we always have more stamina. We will always run the class for little 5, 10 minutes extra, less than that. Well, less than normal category or more than normal category.
Less than
Tell
normal.
me.
Less than normal
Huh?
category.
Okay. That is only because of COVID, you say. Anyway, let's see. I'll try to start after completing some amount. Anyway, by tomorrow I have to complete this up to yesterday. That ether discussion will be less, but some mechanisms and all coming. So today I will complete some more reactions and I will complete. One more reaction for that CH bond cleavage. Sorry, COH bond cleavage. The COH bond cleavage, reaction number 2, that is esterification. Okay, esterification. And these are simple reactions. That is CH3, COOH. And I am taking CH3, CH2, OH. And what will form? Here, remember clearly that you have idea why I am teaching this. Because many of you are still unable to write. When I write left side, see, I have written left side acid, right side alcohol, because the right side alcohol is our chapter, alcohol chapter we are discussing. Okay, but don't worry about that. See, you have the idea about CH3, C double bond O and OH. Remember that acid will be like this. Okay, and then another one is alcohol will be like this. Alcohol will be like this, CH2, CH3. Let it be any alcohol. Okay, and then now what happens? This only will happen. This OH bond only will break. I am not telling it has been proved experimentally. How it was proved, I will tell you later on. And now what is the product? You should write like this: CH3, COO, C2H5. This is actually alcohol part. This is acid part. Okay, so this acid should be, this is the acid. Don't take that here, even if it is even if this C3H7 comes also, some of you will tend to, that's why I'm explaining this. Some of you will tend to write it is propanoic acid like that. No, it is not propanoic acid. Acid part should be this one. The C double bond O is there, this should be taken as an acid part. Let the other side any. So what is the EPAC name? CH3, COO, CH2, CH2, CH3. What is the EPAC name? What is the EPAC name? Tell me. What is the EPAC name here? What is the EPAC name? Here you have to say this is a propyl, secondary prefix, propyl group. N and all will not come. Propyl itself understood in straight line, now EPAC system. Propyl, and this is 2 carbon acid, ethane, ethanoate, ethanoic acid, ethanoate. This is the EPAC name. Propyl ethanoate. Because some of the things that this is hydrocarbon. O starts, no, O, after C, O starts means that is alcohol side. This after C, the C starts means that is carboxylic acid. So this is the parent one. This is one point I wanted to convey to you. Many of you are still having doubt. That's what I told you. Now next is how they put, sir, why can't we this hydrogen? See this, I am using another one color. Sir, why can't we this hydrogen and this OH minus, because anyway minus H2O. Minus H2O, dehydrating agent can use, but here it will be acid hydrolysis, very hydrolysis only, but you can use sulfuric acid or any other dehydrating agent you can use. Many dehydrating agents are generally used, I will give the list, and that water will be pulled up, reaction will be faster. But what is that? There is a technique called isotopic labeling. isotopic labeling. This technique only that the scientists they apply, they proved that OH bond of alcohol was breaking. What is that? What they took is in this reaction, they took some alcohol, not all complete alcohol, they cannot take one drop. Actually, I just gave one drop, but even less than that sufficient. One drop alcohol they took with the iso. See, I am putting this asterisk, that is O18. Okay, O18. What is the normal alcohol is? Normal oxygen is O16. But by special method, we can couple alcohol with oxygen 18 because it is a radioactive type. Okay, so now that alcohol was used. Then after the reaction is over, they separated the ester. The ester was purified and separated, and then they studied. It was showing radioactivity. Tell me, if it is showing radioactivity, what is confirmed? What is confirmed? What is confirmed? Oxygen atom of alcohol is is present in ester. Is present in ester. Okay, this is the proof or not? This is an experiment here. That one drop of alcohol with O18 radioisotope was used. After esterification, ester was purified, removed out of the mixture. So purified pure ester. That ester was checked for radioactivity. It was having radioactivity. That means it confirms that O18 is present in the ester. If O18 is present in the ester, this has broken hydrogen, and OH has come from carboxylic acid. That's how minus H2O happened. So this is called isotopic labeling. Okay, so this reaction belongs to OH bond cleavage. Okay, write down, write down this reaction. And similarly, instead of this carboxylic acid, even ester, CH3 COOR and CH3 COCl. What are they? This is acid chloride. These all of them are derivative of acid. Acid chloride. This is ester. Okay, so they will also form not acid. Right? Acid chloride is that. This is CO. CO twice. This is acid anhydride. Okay, acid anhydride. CO twice. Okay, how the acid anhydride will form? I will just show CH3 COOH, CH3 COOH. More exactly, to make you understand this CO I am writing for your understanding, C double bond O dash. This is C double bond O dash OH. Right? From this, when you use a dehydrating agent like calcium chloride, phosphorus pentoxide, when you use, when these two, here one water molecule will be removed. Once the water molecule is removed, this carbon will make a bond with this oxygen. Okay, so I am writing the structure CH3, C double bond O, and this carbon will make a bond with this oxygen, and then after that oxygen, carbon is there, double bond O and CH3. But this only I am writing what CH3, CO both the side twice, and oxygen. Actually, so you should know that in this algorithm. Only you can go for any particular exam and even for a board exam also. This idea is essential for you. This is acid anhydride. Generally, anhydride means what? Anything losing what is the nitrogen oxides or acid and anhydride of nitric acid or nitrous acid. Means loss of water only will produce that substance. Okay, chromic acid, chromic CrO3. It is anhydride of chromic acid because losing water, this oxide is formed. So we call it as chromic anhydride. Chromic anhydride. Instead of saying chromium oxide, you can say chromic anhydride. So this is acidic anhydride or acid anhydride. They can also form what is that? With alcohol, they can react like acid was reacting. They can form ester. They can form ester. And here we will use pyridine. Pyridine is also a base. Okay, it's a strong base. So pyridine will be used as a base here. reaction. Okay, that I'm telling you one more information. But it is also write down because functional group into functional group. Don't take it lightly. Acid anhydride is a functional group. Acid chloride is a functional group. Oil chloride, oil chloride. Okay, functional group. One function and ester is another functional group. So functional group converted into functional group. Because the ester is function because what for sir, what for it is required, it is there in the textbook. And then after that ester what happens, COO R prime. Ester, I told you one method just now, I told you ester can also be converted into what? That yesterday class we discussed. Because it can be reduced into what? It can be reduced into what? RCH2OH. Because the lithium aluminum hydride is very expensive. And therefore, what we will do? First, you will convert into ester. Carboxylic acid will be converted into ester, and ester can be converted into this one by simple reagent hydrogen and palladium combination. So now that means now the RCOCl is there. We are giving you convert it into alcohol means what you will do? Of course, you will have a very simple method, but still then you can come to your idea. What is that? Pyridine. Pyridine. And here COCH3 one limit, then you add methanol. Ethanol, anything, any because ester only that group will go out. Then convert this. This is one idea. This is functional group, functional group, functional group. Okay, and another one information in the acid chapter I'll give you. RCOCl, RCN, RCO, OR prime ester, RCO twice, O. These are all called and RCONH2. These are all called, we are not going to study them separately chapter, but in acid chapter it will be required. They are all called as acid derivatives. They are derived from acids. Why? How? Ammonia, carboxylic acid will give this. Chlorine reagent and it will give. Okay, cyanide. Then this is esterification. Just now we studied this is dehydration. Okay, so that means for all of them commonly you see you can convert them into RCOOH by very simple reagent acid hydrolysis. But don't forget that. Many places it will help very important information all of you should know. They are all acid derivatives because they are derived from acid. That is why they are acid derivative. But how can you get it back? How can you get it back? Simple by hydrolysis. Okay, this will become, this is where I am drawing the line. This carbon. This carbon will become acid RCOH, RCOH, here RCOH, RCOH. Don't take the CNC. And the CNC only will become COH. Okay, this information, keep it with you, will be helpful for you for many conversion. Okay, so this is the end of this OH bond cleavage. Okay, now let us come to this reactions involving CO bond cleavage. CO bond cleavage. This bond will be. Okay, only CO bond alone will be the first reaction. This is again very important reaction because it is going to help you to distinguish between primary alcohol, secondary alcohol, tertiary alcohol. Now, a new page you open for writing the distinguish between. I hope that you have opened a new page for a mechanism because we have completed one mechanism. Now I give one more mechanism. And similarly, in this reaction, first time you start a new page, distinguish between. Many distinguish between will come. Limited number, not many means not too much. But confirm the question. That is why I am telling you to open. Name reaction, open a new page. So that you can just have, instead of searching the book, you can have it on hand always. Name reaction. Give reason though later on we'll discuss. I already discussed, but later on we'll discuss question wise during revision time. Right? And now here COH cleavage, that is ROH plus HCl. Regarding HCl gas or acid, that discussion later on and come. And hydrous zinc chloride. This HCl plus anhydrous zinc chloride 1:1 ratio is called Lucas reagent. The name will be there in the textbook, but the ratio may not be there. 1:1 ratio is called Lucas reagent. Okay, this is if it is acid, generally it is a concentrated acid. Even sometimes you can take even gas also, hydrochloric gas and zinc chloride. But when you then sometime only without zinc, that point I will tell you at the bottom. Okay, so here what happened? RCl will be formed, alkyl halide. But this is concentrated urine. Then only it will be helpful for you to distinguish. Concentrated means what? Aqueous. HCl more concentrated, but it is aqueous only, right? Hydrochloric acid means what? Aqueous only, but concentrated means more concentrated. That's all. Dilute concentration is telling about how much water, how much less water, more water. So this is, it will be aqueous. But it will be a white colored turbidity will be appearing. You go back to the previous chapter, the physical property, what I told you, alkyl halides are insoluble or less soluble in very less soluble, sparingly soluble. Don't write that less soluble. Sparingly. Sparingly means almost insoluble. They are precipitate. So white color, so that the white turbidity will appear. White color turbidity will be appearing. Because here alcohol and water and all very soluble. So here the beaker will have transparent water-like will be there. But once the reaction is completed, here what happens? That white colored turbidity will appear. Okay, so this is actually reaction that this bond is breaking and nucleophilic substitution. Okay, nucleophilic substitution is not new one, nucleophilic substitution. Right? And now all of you write down. I am coming to this now, how this test is going to, this is called Lucas reaction. And the reagent I told you Lucas reagent. Now how it is going to help you? See, I am writing one CH2OH, a primary alcohol. Okay, so this is primary alcohol. And another one is RCHOH, secondary alcohol. Okay, and another one is COH, tertiary alcohol. R, okay, tertiary OH. Okay, so now here, this is 1 minute. தண்ணி இதெல்லாம் பாருங்க இந்த குதிரை அவரோட விளையாட்டு டெய்லி இந்த சூப்பர் படிச்சு போகிறது சைடில் வச்சேன் okay, so now you will see that I will complete this. See here, primary, secondary, tertiary. Okay, it is going to distinguish secondary alcohol, tertiary alcohol. You tell me in which case the turbidity will appear immediately. Because based on the time taken, rate of the reaction only. In which case the turbidity HCl and zinc chloride anhydrous, that is anhydrous, that combination everywhere I am making. Tell me, think and tell me fast.
Tertiary alcohol.
Tertiary alcohol. Why? Tell me with the reason.
It will form a stable carbocation, sir.
Okay, very good. Because this, first of all, you understand, this reaction, this bond will break. Okay, this bond will break and you will get a carbocation. These are three lines, because it may be R or 2R, 1R, whatever it is. Carbocation. And then after that only, then what happens? Cl minus will react. The Cl minus will form this one. So this tertiary, this is tertiary carbocation. Here what will happen? Tertiary, because all three are carbon, so tertiary. Here what happened? 2 carbon only. One is hydrogen. That means this carbocation. This is secondary carbocation. Here what happens? Only one side carbon, remaining hydrogen. This is carbon, primary carbocation. You know that the tertiary carbocation is more stable than secondary carbocation, which is more stable than primary carbocation. So which carbocation is more stable, that will be forming very fast. Very fast. Okay, because all of them are trying to become this one. But who will form first? That is one which is more stable. Okay, so this reaction means here turbidity appears immediately. Okay, write the conclusion. Turbidity appears immediately is a second tertiary alcohol. Then if it is appearing, then the alcohol taken is a tertiary alcohol. If it is appearing slowly because it is reaction will be little slow. Okay, if it is slowly turbidity appears. Okay, this is secondary. And no turbidity at room temperature. No turbidity because this is very least reactive. Carbocation reaction will not be that. And only when you are heating, turbidity will come. So at room temperature, no turbidity. That is primary alcohol. Okay. So this point you write down how to distinguish. Question will be asked in the exam. Distinguish between N-propyl alcohol and isopropyl alcohol. Distinguish between N-propyl alcohol, isopropyl alcohol. This will be the board exam question. Then what you will do? Don't simply write by Lucas reaction. Don't say that they'll give only half mark. The question may be 2 mark question only. Don't lose that. Explain. Okay. That is, both the alcohols are treated with Lucas reagent. Okay. And in case of isopropyl alcohol, the turbidity appears slowly. In case of N-propyl alcohol, no turbidity forms at room temperature because it is a primary alcohol. And isopropyl alcohol is a secondary alcohol, so turbidity will slowly appear. So from this, I am giving you two test tube. I am telling you one test tube is isopropyl alcohol, one test tube is N-propyl alcohol. I will not say that which is N-propyl, which is, but I have already told you one is isopropyl, one is, but you have to identify which one is isopropyl. Then go to the lab and take this Lucas reagent, carry out, you will be able to find out. That's called distinguish between. All of it clear? Okay. Similarly, very fast appearing that is tertiary alcohol. Okay, so this is reaction number 1 under the heading CO bond cleavage as well as and that was that distinguish between also it is helping right now. Anyway, so considering your you'll see that I'll just end up let us see. Okay, anyway, I think tomorrow time will be enough to complete the leftover reaction and as well as the chemical properties, preparation properties of ether. So we'll wind up now. Tell me any question from your side? Any question? Any question? Tell me yes or no. Any question? I'm writing only message, not talking at all. I don't know what it is.
No, sir.
No, sir.
Okay, right. Many no sir is there in the message, but generally I don't see the message because only that board screen will be there. Right, okay. Thank you. Thank you. Leave then tomorrow again. I think not delay tomorrow. Sharply 10 o'clock. We'll start maximum. No change will be there. Okay. Join at 10 o'clock and 15 minutes in advance. Okay.